That's it.
Yeah. I think the biggest challenge for me is taking a test, and I've never taken a cert before, so I have anxiety, and especially test anxiety, because I don't know what to expect.
Mm.
So half of my battle is fighting that. But now that I failed it once, I'm good. As stupid as that sounds, that it's just something I know about me. So even going forward, when I do Security Plus and other things, it's like, okay, now I understand how CompTIA does this, and I don't have to sit and overanalyze and overthink things leading up to the test.
Well, you're building up your confidence. That's another thing.
Yeah. Well, and then I also have testing strategies too, you know, that I can work through. That's going to help me, you know.
Help ease your stress.
Yeah. Ready whenever you are, Ralph.
I don't know how well you guys can see that.
It looks great on my end.
It's not bad.
I mean, unless you start writing small and very chicken scratchy, I can read all that.
Yeah, I'll just try to take my time. I'm sorry I don't have really like a tripod or anything special here. I'm kind of up in my kid's playroom.
Snyder.
Yeah. You can see I got a little Skylander over here, you know?
Awesome. Yeah, we used to have Skylanders, and then we switched over to Infinity.
Yeah, those are over there too.
I like the Skylander. My kids love it.
Yeah.
Yeah, they just binge watched all the episodes of the Skylanders, and now they have nothing else to watch.
I hear you. Well, I'm ready when you guys are, so.
I think this is it, because Jeff, he usually shows up, but he said he's not going to be in, and I don't see Stella, so I don't think she's going to be there, and that's pretty much who's been showing up, so.
Okay. Well, that works for me. I'm going to kind of do this on the ground so you guys can hear me okay and see this. So I'm ready whenever you are.
Okay. Fire away.
Okay. So I'm going to try to explain a little bit on CIDR notation for you guys, which also we call slash notation. And just ask questions if you guys have them so we can make sure you guys feel comfortable with that.
Okay.
So hopefully you're up to the point, like I just taught this today in one of my classes, or some of this. Hopefully you're up to the point where you understand the IP address is required for communication, obviously. Now, when you look at the IP address, basically it's in classes, and you guys probably already know that too. So you got Class A, Class B, and Class C, which are your typical IP address subnet classes. Now, we call those classful subnets, okay? So classful subnets basically means that the subnets themselves, they're full. They don't change whatsoever. So it's always going to be for Class A and class full 255.0.0.0.0, okay? And for Class B, it's always going to be 255.255.0.0. And for Class C, it's always going to be 255.255.255.0. Okay? Those don't ever change if it's a classful subnet. Okay? So when you're looking at these values, and hopefully you guys got to this point too, maybe, maybe not, I don't know. When you look up here, you've got the lowest value you can have with an IP address or a decimal for IP is 0. That's the lowest. So if you take and you convert that to binary, that's all zeros. Now, did you guys do the binary conversion yet?
I understand it.
Okay, that's good enough.
Ish.
So
Yes.
if you get the decimal into binary, that one's all zeros, and then 255 is all ones. Okay, so that's the lowest and the highest value you can have. So when you're looking at your classes of subnets here, that means that if it's a Class A, then that first octet is 255, then that's 8 ones here. Okay, and the rest are all zeros. So hopefully you saw that. And then, of course, you can see that from here, too. If you go down the line for all of your classes, you can see that you can find where the all 8s are and where the 0s are. Okay. So from that point on, what you're looking at here is the network bits. Okay. Network bits are all 1s. Okay. So if it's a network bit, it's equal to a 1. If it's a host bit, it's equal to a 0. Okay. So that's what you're looking at here. These are network bits, and those are the 0s are the host portion. So when we actually reference an IP with a subnet, typically we don't reference it or all the time in a dotted decimal fashion. So what we do is we make that as a shorthand in what's known as a slash notation. Now, slash notation, basically what that means is it's going to be a slash in the front, a forward slash, always a forward slash, never a backslash. And whatever is the number of network bits, okay? So if you're adding these values up here, the number of network bits is for the class A, an 8. So that would be a /8. This one for class B, you've got 2 8s. So that's a /16. And for a class C, you've got 3 8s, which is a /24. And all I did there was I just added up what are the network bits, which are the 1s. Any questions there? So far, it's okay?
Oh, yeah, that's cool. I didn't realize that.
Awesome. So the problem becomes now on networks where you want to be able to be a little bit more flexible with the address space. So here, if I'm stuck with these subnets, nothing really changes, right? I'm set with a certain value of what I can create, and it's not really flexible. But one thing you'll probably know on networks today, you want to create different size networks for customization, as well as not only just customization, but also efficiency. So what happens next is we want to be able to look at the subnets that are in between these values, okay? So they're still considered class A, they're still considered class B, they're still considered class C, but they're not the class full subnets. They're the ones that are in between, which are known as the classless, right? And so here when we say CIDR, we usually refer to that as the classless interdomain routing, and that is usually referencing the addresses that fit between these classful addresses. Does that make sense? So far, so good?
Yep.
Okay. So now let's look at that, okay? So when we're talking about classless interdomain routing, you come in here and you say, okay, what does that exactly mean? Well, if I have a need for a certain number of computers, okay, on my network, and I want to customize my subnet for that, that's when you're going to use this classless interdomain routing, okay? So in a second here, I'll show you an example of doing just that, okay? But before we get to that, let me show you what the values look like and how you can kind of list them out, okay? So I'm going to do from class B here all the way through class B to get to class C. So if we're looking at the first value for class C, you can see it here, 255.255.00, and that's /16. These classful subnets are always used as kind of a baseline. So as you're moving in between them, you can use these as a good reference point, okay? So now, you probably have seen this table up here. This is referred to as the power of 2 table. So when we're doing binary conversion, we use this power of 2 table to help us represent an octet. So what we're going to do now is if we want to see the values between a /16 and a /24, how do we see those values in CIDR notation? Well, we come over here and we say, okay, what octet does not currently have network bits, excuse me. And you can look at it, and of course, you see this first one, this third octet. So all the change that is going to take place for this transaction is going to happen in that third octet. So what do? Well, when we're adding networks or network bits, we start adding it on the left side because that's where the network bits are, where they reside. So what you do is you come in here, and what the next one would be from 16, of course, going to be 17, right? So how do I get that? Well, I add a network bit right here on the end, okay? Once I use that, I turn the rest of the binary values off, or excuse me, the rest of the values off at the top of the table. And that now becomes what my value is. At 17, I've now added a network bit to the transaction of this octet. And so what that becomes now is 255, 255, dot 128, because now I've turned on that number. So I turned that 128 here. And then of course you've got your last octet you can't forget about, because it's always with IP version 4, we have 4 octets. So this is a /17. And then all you do from that point forward is you keep adding ones. So you come over here and say, okay, well, what's a /18? You just add another 1 right there. And so now I turn the rest of the values off again. And now I have a 255, 255, and then I add 128 plus 64, and that gets you 192. And then you can't forget your last 0. So that is a /18. And you just continue down that line using adding a 1 each and every transaction. So eventually you'll figure it out. It'll be, okay, the next one, I'm adding another 128 plus 64 plus 32. Well, that's 224, which is a /19. Then I add another one here in the 16 column. And that'll be 255, 255, 240.0, and that'll be a /20. Then I add another one in the 8 column. It'll be a 255, 255, 248.0, or /21. Then I add a 1 in the 4 column. And you go all the way down the line until you get to 24. So it'll be 250. 252. And then it'll be 252. At 23. And then I ran out of space. Oh, wait a minute. Did I skip something here?
Yes.
I did. Where did I skip? 240, 248. What am I missing here?
Yeah, when you wrote the 250 for the 22, it's supposed to be 252 there instead of 250.
I got you. You're right.
252 is supposed to be 254.
I'm sorry. Correct. So if you add 4, it's 252, not 250. My bad. You're absolutely right. So that's 22 and that's 23. So basically what you have here is the column of values that it started at /16 and then kind of moved through, and all it did each time was add a 1 and then kept adding a 1, and each time it changed that value. Now you could do this same thing between a class A to a class B, but the column that would be this one, this third column, would be shifted over here to the second column. It would be the same values, but on the second column instead, or the second octet. Then if it was between a class C and then all the way up to 30, then it would be on the last octet that these numbers would come in. So now that's how you would basically know how to go through and understand what is the CIDR value based off of a slash notation. So I could give you easily any slash value, and then you know based off this baseline where to start, and then from there you can either go backwards or you can go forwards based off of whatever your preference is. So I could come in here as just an example. I could go in and say, okay, give me what is a /20 12. Okay, so I know that 8 here is 255, so it's going to be at least 255, and then we have to add 4 values. So then all we do is we add 4 to the side here at the front. 1, 2, 3, 4, and then I've got 12. So I turn the rest of the numbers off. I calculate what's 128 plus 64 plus 32 plus 16, which is 240. And then because I'm doing a slash A or a class A, we would basically also have to not forget the last 2 octets. So a slash 12 would be 255.240.0.0. All right. What questions do you guys have?
I don't have any. I actually never seen it explained that way, and I wish it would have been previously.
Yeah. Once you figure out it's just enough, and I told my class today, I said, if it helps, you can just draw a bunch of 1s and 0s. You're going to get to 32 no matter what. And then once you see that, you can actually start to figure out what these numbers are.
Well, it makes so much more sense now.
Mhm.
You're awesome.
No problem.
This is definitely one part of Network Plus or CCNA I'm pretty comfortable with.
Oh, good. So the next step, okay, now that you've got the CIDR notation, okay, let's see if you guys can get this one. This will be fun. So now somebody's going to be designing a network based off of what we just talked about there, okay? And what they'll say is, I need a network that's going to support, let's say, 65 IP addresses, okay? And your job now is to figure out what subnet is going to support those 65 addresses based off of this CIDR notation, based off what we looked at. Now we have to come up with what subnet we want to design for that many IP addresses, okay? So, there's lots of methods to do this, and if you guys know one already, stick with what works. I always tell my students, always better to do what you know. But one way that I know that is real easy to get is 3 simple steps. Every single time, if you do these 3 steps, it'll give you the right subnet, okay? So the first step is to put your number down, right? Because that's what you really need, right? 65 IP addresses. Now, when you're creating an IP subnet, you always have to account for the subnet address and the broadcast address. So the subnet address is the first address, and usually, sometimes it starts with 0. The broadcast address is usually the last address. And basically what we have is we're framing up what is going to be the entire subnet that we're going to use for our network. Okay, so we have to always incorporate these 2 when we're doing this type of equation. So what we do is we add 2, which is going to get us to 67. So you always take your number, you add 2, and you get 67. Okay, and then from there, you basically need to figure out what the lowest exponential value is, which is usually the host bits. Because if we look at it, if we know the host bits, then determining what the network bits is, well, that's just what's left over. So in order to get the lowest exponential value, we use this table of power of 2. So I'll put that up here real quick. 2, 4, 8, 16, 32, 64, 128. Each one of these has the exponent value, and we're looking for a number that is either equal to 67 or greater. 64 is too small, so usually what we do is we kick it up to the next one. And in this case, it's going to be 7 is the exponent. So we know in order to accommodate basically the address space we need at least to use the exponent of 7, which is the host bits. Then what you can do is you can take the total number of what is in an IP address. So if you think about IP version 4, we've got in an IP version 4 address 32 bits. And then you subtract those host bits, well, what's going to be left over? It's going to be the network bits. So that gives us 25, okay? All you do is put a slash in the front of it, and now you know what the subnet is that's going to support that many IP addresses. So that's the relevancy to some of this, is when you're building networks, you want to know what subnet supports that many hosts. And so if you don't know how to do the conversion part, well, you'd be stuck at 25. But for the Net Plus, they want you to be able to convert that out. So that's 24, and we'd add 1 for 25. So now we know that 255, 255, 255, 128 would actually be the subnet that would support that many hosts. So that's kind of seeing it through, so to speak. So being able to do the conversion, kind of understand the importance of it, but then seeing the relevance of, if you need to build a network, figuring out what subnet's going to support the many hosts that you need, the IP addresses. All right, any questions there?
Yeah. In step 3, kind of lost me a little bit. Where did you get the number 32?
So 32 is the number of total bits in the IP version 4 address, because IP version 4 is a 32-bit address.
Okay.
And then the 7 that we have here is actually the number of host bits. So what we're seeing here is the subtraction of the host bits from the total bits, right? That's going to give you the network bits. And if you go back, we saw, of course, obviously the subnet, that's what we use a subnet mask for, is a way to represent the network value for the IP address. So everybody's going to kind of share that subnet mask that's going to be a part of that network. All right, so I'm going to let you guys try it out. This is more interactive than not, right? So I want to make sure you guys see it. So before I let you go, because I do need to jump off, see if you can figure out what a slash, let's see something. Let's do a slash 27, convert that to dotted decimal, and then also let's do the formula here so you guys can see what subnet you will use. Let's say you need to get, let's say you need to support a lot of hosts. So let's say your number is going to be something like 350 computer IPs. Take a few seconds there and see if you guys can figure that out. And then we'll go over it real quick to wrap it up. All right, you guys about ready?
I'm probably going to need to see how you work through it.
That's okay. All right, did anybody get 27? What's 27 in full decimal?
224.
Okay, so put 255, 255, 255, right? Because that's 24.
Right.
And then you said what was it?
224.
224. Okay. So we should already know from what I showed you guys that this is 8, this is 8, and this is 8, right?
Right.
Okay. So now we got 24, and again, that's our good baseline. And we just need to get to 27. So all we need to do is, to get to 27 from 24, is add 3 bits, right? So if we go to our table that we have, right? We just put 4 bits, 1, 2, 3, 4. And we just take that and convert that from binary to dotted decimal. And sure enough, that's 240, I think. That sound right? 27, 24, 25, 26, 27. 3, excuse me.
There, you definitely say you did one too many.
Yeah, you know, I tell you, it's late in the day. Perfect, right? So now we had to add those 3 in there to the 3/8 to get the total of 27. So all it did was use the baseline of the classes, which is 8, 16, and 24. I know it's at least 24. And then I say, well, how do I get to 27? I just add 3. And then I use my table to go 1, 2, 3. Add these 3, 128, 64, and 32. And that gets me 224. Okay? All right. Did you guys, anybody get the IP subnet that we want to use?
255.255. Dot 248.
248.0?
Dot 0, right.
Okay. So in this one, remember what we did was we take our 350, we have to add 2 because of the subnet address and the broadcast address. That gets us 352. That's step 1. Step 2, we look for the lowest exponential value, which is what value is equal to or greater than 352. Now this time we had to go further because we only went to 7 last time. Yeah. So 2 to the 8th would be double that, which is 256. And 2 to the 9 would be double that, which is 512. Okay. So that's the number here, because this one's too small, and our exponent then becomes 9. So our exponent of host bits we want is 9. Our step number 3, we go in and say, what's the total number of bits in the IP version 4 address? 32. And we subtract out 9, and that gives us 23 as our slash subnet. Is that right? Let me check my math.
Yes.
Yeah, that sounds right.
Slash 23, yes.
Okay. And then to convert that from slash to, again, our full decimal, that's why you want to kind of really get comfortable with doing that, is, you know, use your baseline, which again, in this case would be our 16, because that's 2 8s right there. And then I need to get to 23. So I can come up here. I'm going to erase some of this so we have more space. So I go 16, 17, 18, 19, 20, 21, 22, 23, and then put that last 0 in there. So that'll be enough. And you can count them up 1, 2, 3, 4, 5, 6, 7. And then if you convert that from binary to decimal, you should get 254. And then don't forget your last 0. And that's it.
I'm definitely going to need to practice this.
Is it 254?
I don't know. Hold on a second.
I think it's 248.
All right. So
talked about. And
let's
then
make sure.
I think you got an extra.
This was 23, right? All right. So
slash. Yeah, I got a slash 23.
Okay, that's good enough. So then if it's 23, we've got 8 and 8. That's 16. So then I go 17, 18, 19, 20, 21.
You're right, it's 254 because the 248 is too much. You're right. 248 is too much. 254 is right. So
okay, that's okay. It's all learning.
But I was looking, since we came to, we chose 512 would be what we needed, right?
Correct. So
we gonna have more. So I don't think we turn on the bit under the 2. Shouldn't it be off? And that's why I chose the 48, because 23 is part of it, right? So it should be off, right?
I don't think so. Because again,
you got 256 as part of it, so that's the 1, right? On the third octet, you got the 1.
Yeah. So
Oh.
if you put all ones, it's 255.
And then with the 1 here, you turn it'd be 256 because you added it.
No, you're getting confused. So
Nope,
basically,
you're going into the third octet, right? We working
no,
from the third.
256. 256 is if you include 0.
Right.
So basically here, what we're doing is we're not including the 0
Okay, I understand.
because we do it here. We add the 2 in there.
But we wanted 352, so we got to include the 2 to get the 512, right? We turn it on or do we leave it off?
Oh, yeah, we turned it on.
Okay, so that's the one we count then. Okay.
Mm-hmm.
Okay, yeah, so it is 254. I guess the 248 that we said earlier, I guess that's wrong. Then it's 254 then.
Yeah, that's okay.
Okay.
All right, so practice that. If you're comfortable with the CIDR, what you guys need to do is say if I throw out a number to you guys. So if I say, man, you're building a big subnet and it needs to support, I don't know, 150 computers. You need to figure out what would be the subnet that would support that. And just keep bouncing off of that. And then between that and giving out these CIDR notations, just get comfortable with those, because your next step really is, and this is kind of the flip of it, what you got to do is if I give you a subnet, you need to figure out how many hosts are supported on that subnet. So you need to go kind of in a different direction to figure out what is going to be the host count that's supported on a given subnet. But if you get stuck there, let me know and we can do another little session.
Okay.
Because eventually what you're going to try to do with the Network Plus is you're going to try to get to where you can feel comfortable with subnetting. And the best way to get comfortable with subnetting is kind of build these little scenarios up. Like first you start with converting to binary. And then from converting to binary, then you go in and start looking at, okay, well, what is CIDR? And then from CIDR, then you start saying this stuff like, given the number of IP addresses, what's the subnet? And then you say, okay, given the number or a subnet, what's the host number? And then from there, then you can start saying, okay, given an IP address and a subnet, what is this particular IP address broadcast address? What is this particular IP address's subnet address? What is the range of IP addresses in this particular subnet? So that's kind of what it's leading up to, is basically all of this stuff leads up to getting that ability to kind of do subnetting.
Yeah, because I thought I understood it until I took the test.
I got you.
But
Well,
yeah,
if you,
this will help. I'm gonna try to find like maybe a worksheet or something to like work through that, because I just need to get more familiar with the math. I'm just horrible at it. I have to practice it over and over again.
one website I love for the practicing part that I tell people when I teach Network Plus is subnetting.org, I think is the website. You might have to look it up, but basically the cool thing about it is it gives you a lot of questions. So you can keep that repetition of just kind of going through it until you feel comfortable with the concept there of subnetting.
Oh yeah, yeah. Yep, subnetting.org.
That's a really good one. But if you guys, again, want some more of that stuff, if you start getting comfortable with this and this is good, then we could probably have another one that goes through those next couple phases so you can learn the whole subnet parts.
Okay.
Subnettingquestions.com is a good site too.
Yeah, that's another good one.
Okay.
But yeah, the more practice you can get, because another thing that'll come up on the test sometimes, they'll ask you, given this IP address and this IP address and this subnet, are they on the same subnet or not? So that's another thing you have to kind of be able to do. And a lot of that involves understanding a bit about, do they have the same network ID? And if they have the same network ID, yeah, sure enough, they're on the same subnet.
Yeah, I think that's where I was. I think I had a question that was phrased like that, and I was like, I don't get it. It has the same slash, and I'm just, there's something I'm missing.
And I can show you, again, that can be something else we can set up during that time as well.
Okay. I think this is good. I can work with this, and I know Stella will appreciate it too.
Yeah, definitely. And just challenge yourself. I mean, try a couple different ones and make sure you feel comfortable with that CIDR back and forth. One of the things I saw a lot on the test is just kind of being able to do the binary conversion. I mean, that's the big first step, being able to kind of go back and forth. And if I give you a binary, go to decimal, and then decimal to binary.
Do you know if they're going to have where you have to convert to hex on the test?
So once you get to looking at MAC addresses and IP-version-6, all that stuff uses hexadecimal.
Okay.
And it's pretty easy. I can show you guys real quick if you want to see how to do it.
I mean, I get it. It's frustrating because I'm like, I know I can use my simple calculator on the computer.
Yeah.
That's the sucky thing. So, but obviously can't use it on the test.
Mm-hmm. But yeah, usually what they do with hexadecimal, they just kind of use what's called a nibble, and they just break it right here into two parts, four bits each, and then from there, because a hexadecimal value can be 0 to 9, can't go to 16. You got to break it there, and then basically what I do is I usually just cross these out, make it 8, 4, 2, 1, like that, and that way I can know exactly. Okay, this is the first hexadecimal value. This is the second hexadecimal value. But I would doubt it very seriously that you see a whole lot of that. They got so much on the other stuff that it'd be pretty rare to see something like that.
You probably wouldn't see that on Net Plus.
Yeah, I agree.
Definitely on CCNA, but or CCNP, but
yeah,
not the not the Net Plus. Okay. That's the good part. That's the good part.
Yeah, that is.
Got to find that silver lining somewhere.
Exactly right. Okay, guys, I got a scoop, but okay. if you come up with something else, let's definitely meet up again and try it out again.
Thanks, Ralph.
Absolutely.
For sharing your time.
Absolutely. See y'all later.
All right.
All right, so it's just us two.
Just us again.
Or do we want to do like maybe another night when we got more people?
I think we started late. We had a full training session. I think it's something to kind of dive into if you hadn't before. But I think the subnetting questions.com is a good site to go to. And I mean, what it's going to do is going to give you a simple question. And if you understand the concept, when you start going here, you can do it quite easily. It's not too terribly difficult, but if you don't understand, like you were saying, it'd be a little challenging. And it's just a simple worded question like, what valid host range is the IP address? And they give you the IP address with the subnet mask and ask you what is a part of. And it's a simple question, but if you're having a challenge with it, you wouldn't get it. But if you understand just the basic concept, like what Ralph was talking about, you can get the answer. But the beautiful thing is, even if you don't know the answer, you click on the answer and it'll show you the range that it falls in. And then if you don't understand, you ask yourself, well, how did they get this range and how did they get to this point to pull it up? Right. And
yeah, it looks like they're kind of the similar websites. But yeah, this will be good to practice it because that's me. I got to get that muscle memory.
Yep. You got it. You got it. And you've been facilitating us through this whole process, so you're gonna be all right. And we're here for each other. So to me, if I can just impart this website to somebody to help them, hey, that's great.
Exactly. I mean, like I never heard of the Professor Master until someone had said it on the group, and I was like, well, let me go check it out. And I was like, oh, well, this is cool, So yeah, I definitely appreciate knowledge sharing.
Of course. And if you get a chance and want to look at another avenue, I think the Cyberry for Network Plus. Well, what I was doing, what helped me understand all of this more is I studied above Network Plus. I studied the CCNA. And it helped me with Network Plus. It helped me so much more with Network Plus because I think the instructor for that certification for CCNA is so much better than the instructor for the Network Plus one. And he seemed like a young guy. He's just getting into he's just really getting into instructing.
Mhm.
And you can tell through his demeanor and his body language and everything, and then somewhat in the comments they write, okay, he mentioned this, but it's really this. He's made a few small mistakes, but I guess that's bound to happen when you're starting, being an instructor, that you're gonna overlook some aspects of it.
Okay.
But the CCNA part of it in Cyberry is excellent. It may be more than what you're looking to do because it's preparing you for a higher cert.
Mhm.
And most people have more of working knowledge
Yeah.
with networking than without it. And the good part is, you get the Network Plus and Security Plus, A Plus, those things under your belt. CCNA or maybe going another security route would be ideal for you at that point.
Yeah, they all build on each other. So the assumption would be if you start higher, that should still help you if you decide to circle back around.
Right.
Yeah. Okay, cool. Well, I'm cool with calling it a night and saving this quiz for another day.
It sounds good.
I found I used a different feature on that website. But I know I'm not going to know some of it because I'm still studying it.
It's all right.
But it's definitely to look at it a little bit different, but we can do it another night. So.
Okay, sounds good.
Cool.
All right.
All right. Well, if I don't see you Tuesday, right? Tuesday's the next meeting. I should be able to be on Thursday.
Okay, Tuesday, you mean
The Cul-de-sac meeting.
the cul-de-sac? Yeah, they're gonna be at Conquest.
Mm-hmm.
Okay, yeah, I went down there once before with some of the guys. So yeah, I might try to get there.
Well, I'm gonna try to go. So I wasn't at the last one, so. But all right. Have a good night.
All right, you too, Sandra.